Okay, hello. In this video, we'll be looking at equilibrium of forces. A lot of things to see here. Equilibrium of forces. A body is said to be in equilibrium if it is not moving. That means if it is at rest or if it is in constant motion. Okay. We can also say that a body is in equilibrium if it is not accelerating. That these are different ways of saying the same thing. So either a body is at rest or a body is in constant motion or uniform motion. We say that that body is in equilibrium. Okay. Now, consequently, a body is in equilibrium if the resultant force acting on the body is zero. When the resultant force acting on the system is zero, it means that that body is in equilibrium. Now, consider a system of two forces in the diagram below. Okay, we have two forces. We have F1 and we have F2. Okay. Now, the system above is in equilibrium. So, if the system is actually in equilibrium, it actually means that F1 will be equal to F2. F1 will be equal to F2 because of equilibrium. Okay. This is for equilibrium of two forces. Okay, so let's see further. Look at this question here. It says if the system above is in equilibrium, the tension in string Q is okay. Even though we don't have the correct status here, I think I have the question here with me. This guy is supposed to be 5 newtons here, the last block. This guy here is 4 newtons. And why this is 2 newtons. Okay. Now, if the system is in equilibrium, above the tension in the string Q is now. The answer is the tension in the string Q from this string Q is acted upon by two forces. Forces act downward. And what are those two forces? 4 and 5 newtons. So altogether will give us what? 9 newtons. So the answer to this question is 9. If we are asked to find the tension in sorry, that's a mistake. Okay, so we have here to be 5 newtons, we have here to be 4 newtons, and we have here to be 2 newtons. And we want to find the tension at Q. Okay, the tension at Q, oh yes, that's correct, 4 plus 5, 9, sorry, that's correct. Okay, but if I want to know the tension at R, the tension at R will be a sum total of all the forces. That means 2 plus 4 plus 5. Or the tension at R, will be just 5 newtons. The tension at Q will be 4 plus 5 newtons. The tension at P will be 2 plus 4 plus 5 because all of them are acting on P. Their weight is pulling P down. Okay, so that is for that. Now here we see equilibrium of three forces. The equilibrium of three forces can be explained using the triangular law of forces, Lami's theorem, and resolution of vectors. So you're going to be seeing each of them. Here, the triangular law of forces states that three forces in equilibrium can be represented in magnitude and direction by the three sides of a triangle taken in order. So you see here, when three sides of a triangle, look at those three forces, F1, F2, and F3. The three of them are in equilibrium. So since they're in equilibrium, we can represent them in the form of a triangle. Now look at the next statement. To represent this in a triangle, we draw coordinates first, then trace the forces, all arrows pointing head to tail, head to tail. So this is what I do. You can look at this here. You can start with any of the forces. Let's assume I start with F3. F3 acts downward. We want to represent it in a triangle. This is F3. After F3, the next is F2. F2 is acting this way, you see, F2. This is F2. Then after that, you have F1. F1 is acting this way. You know, this is F1. So have you noticed that these three forces now has now been represented as a triangle? And each of the forces must be following each other. Like you see F3, see F2, and see F1 is tail head, tail head, tail head. That is very important to note. So let's see a question here. This says find the value of F and T in the figure below if the system is in equilibrium. Now, if three forces are in equilibrium, the first thing I can do is to represent them in a triangular form. We may have different diagrams, but we can still be correct. It's just to follow. Now, I'm going to draw this before I show you. I want to start with the 50 newtons force. It's going downwards like this. So I'll write here 50 newtons. After that, let's continue with force F is perpendicular and going this way. This is force F. Then after that, you have your tension, which is going this way. This is your tension T. You can see that I have represented it in the form of a triangle. This is perpendicular. The angle T makes with the vertical. The angle T makes with the vertical is 20 degrees. So that's what we are going to place here, which is 20 degrees. This is beautiful. So looking at this now, I can apply my rule, SOHCAHTOA, to find the value of F and T. Like I can see that F all over 50, F over 50 is equal to, that's opposite over adjacent, is equal to tan 20. Okay, so that means F now will be equal to 50 tan 20, which you can use your calculator to sort out. The same thing with T, F and T, F over T is equal to, F is opposite of 20 degrees, T is hypotenuse. So opposite of hypotenuse is sine. So sine 20. Okay. So with that, I can find the value for T. Or we can just say 50 over T. Let's use 50. Okay, let me rub this off. Since we already know the value for 50, we can say 50, which is adjacent, all over T, which is hypotenuse, is equal to cos 20. So that means your T now will be equal to 50 divided by cos 20. And that will give us the answer. We can use our calculator to get that done. Okay, let's see what I have typed here. Okay, so look at that. Exactly. If you notice, this is a different drawing from what I had. Here we started with 50 newtons, the one downwards. Then afterwards with the F, and afterwards with the T. Okay, that's the same thing we did. And the above triangle is a right angle triangle, right? So we have done that for you. Now let's see Lami's theorem. Now with Lami's theorem, if you have three forces in equilibrium, let's say you have F1, F2, F3, and you can see that on the other side, they are facing an angle, like F1 is facing an angle alpha, F2 is facing an angle beta, F3 is facing an angle gamma. So those three forces are, according to Lami's theorem, F1 over sine alpha is equal to F2 over sine beta equal to F3 over sine gamma. We want to use that principle now to solve this question. Now, let's look at this. This angle here is already right angle, that's 90 degrees, so we already know the angle. Remember that because this angle is 20 degrees, it means that this angle here, the whole of this angle will be 20 plus 90, which is 110 degrees. So that is what it is, 110 degrees. Now, Somebody may wonder, let's do that quickly. You know, if I erect a line here, if here is 20, it means that here will also be 20. That's what we call alternate angles. The rest here is 90, making it altogether 110. Okay, so please you know that according to alternate angles. Okay, so if 90 plus 110 is 200, so that makes the rest of this angle to be 160 degrees. Now in that case, we are going to have something like this. This is F, this is this. Here is already 90, here is 110. Okay, then the rest is 160 degrees. This is our F, these are 50 newtons, and these are T. So according to Lami's theorem, I can say 50 all over sine 110, sorry, let's okay, 50 all over sine 110 is equal to, for F will be F all over sine 160. Okay, sine 160. And with that, to make X subject of formula, we are going to have F now to be equal to 50 sine 160 divided by sine 110. Okay, so if we use our calculator here, you'll see that we are going to get the same answer as we got in the triangular law of forces. You can try that and get back to me. The same thing with T. If you want to find T, maybe I rub this off. We need to get T. T is facing 90, so I can say T over sine 90 is equal to 50 over sine 110. 15 over sine 110. So we can cross multiply to find the value of T. That means T now will be 15 sine 90 divided by sine 110. Now that is very, very important for us to note. So make the calculations and let me know. So this is what Lami's theorem is all about. Now look at this question. It says a mirror of weight 75 newtons is hung by a cord from a hook on the wall. If the cord makes an angle of 30 degrees with the horizontal, the tension in the cord is, well, this is the diagram. That's the rope. This is the mirror here. Okay, and this is the tension. The tension is here. The tension is here. This is where the nail is, supposed nail, where it is hanged. Okay, so the diagram here, this is the weight of the mirror. Weight always acts downwards, so 75 newtons. The tension is always acting against, tension is an opposing force, always acting against the original force. Okay, so this is the diagram we have. Now I can use either the Lami's theorem or the, what is it called now, triangular law of forces. Remember that it makes an angle of 30 degrees, so each tension makes an angle of 30 degrees. Okay, let's use triangular law of forces to answer this question. Now I start with my 75 newtons is acting downwards, and I continue with one of the T's which is acting this way. So this is T, the other T is acting this way. This T, that gives me a triangle. Remember that each T makes an angle of 30 degrees to the vertical. In my triangle here, I don't have any vertical, so if it makes an angle of 30 degrees to the vertical, it makes an angle of 60 degrees with the, with the horizontal, it makes an angle of 60 degrees with the vertical, so because perpendicular means 90 degrees, so 90 minus 30 will give us 60. That means here is 60, here is 60, and if this 2 is 60, it means that here is also 60 degrees. And since it is 60 degrees, this is an equilateral triangle. it means that each of the tension is 60 degrees. 60 degrees. I mean, each of the tension, sorry, is 75 newtons. Each tension is 75 newtons. 75 newtons. Why? Because in an equilateral triangle, all the sides are equal. We don't have 75 newtons in the option, so, but that is the answer, 75 newtons. But for some people can say that the total tension acting on the string is 75 plus 75, which makes it 150. Okay, that's important. Now look at this question. It says the body P shown in the diagram above is in equilibrium. If the mass Q of the body is 10 kilogram, calculate the tension T in the string. Okay, so the mass is 10 kilogram, meaning that it's acting downwards. 10 kilogram means 100 newtons. I've told you before, if this angle is 60 degrees, it means that this one here, which is, this is already 90 degrees. This here will be 60 plus 90, which is 150 degrees. That's if I want to use Lami's theorem. Okay, so 90 plus 150 is 240. Makes the rest of the angle 360 minus 240. Makes the rest of the angle 120 degrees. So we are going to have something like this. Like this. Like this, okay? So this is your F, this is 100 newtons. And while this is your T, the tension. Here now is your 120 degrees. Here is your 150 degrees. And of course here is 90. So since we are asked to find tension, I will say T over sine 90 is equal to 100 all over sine 150. So that means T now will be 100 sine 90 all over sine 150. So I have my calculator here. So let's do that quickly. So we're going to have 100 sine 90 divided by sine 150. So the answer I'm getting here is 200 newtons. So we say equal to 200 newtons. Now this formula I use now is Lami's theorem. Let's use the triangular law of forces to solve this also. So let me rub the whole of this off. Okay, so now according to triangular law of forces, I'll represent them in a triangle. Remember the weight here acts downward, 100 newtons. So this is the force this way, this is the tension this way. So I can start with the weight. I like to start with the weight. Then I have, let me do this, the tension this way, T. This is my weight, 100 newtons. Okay, and force is this way, is perpendicular. So the angle between the weight and the force is 90 degrees. So here is 90 degrees. And this is the force F. So it's obvious that F is, okay, we are looking at T. So 100, the angle 60 degrees is the angle it makes with the tension makes with the vertical. This is the tension, this is the vertical. So the angle between them here is 60 degrees. You see how I do this? So we can say that 100, which is adjacent, all over 60, all over T, which is hypotenuse, is equal to cos 60. So that means T now will be equal to 100 over cos 60. Use your calculator. 100 over cos 60 will still give us 200 newtons. That is to show you how correct both formulas are. Now that leads us to another topic, moment of a force. Now the moment of a force is